Hello everyone and welcome back to ElectroHobbyTube. Today we are going to be talking about LEDs and forward voltage and how to appropriately power an LED, find out what the LED's forward voltage is, and using the resistor, the appropriate resistor, to power the LED. Today we're working with 5 volts, so let's look about what forward voltage is. So forward voltage is V with an F. There are other symbols similar to this, but that's what we're looking for today. Forward voltage. How do we find forward voltage? Okay, so I will bring in the meter. Here we have my meter. I'll put it on to diode, and what we want to do is we want to check an LED. Wrong polarity. Wow. Okay, so all these LEDs are set in a particular order, all ready to be illuminated and checked. So here we go. 1.8 yellow, just slightly below 1.9. The green, 2.3. The blue, 2.5. This one's violet, it's not UV, but it's 2.5, a little bit slightly different. This one is from the Christmas tree we made earlier. See how it changes? It's up and down all over the scope. That's because this has another semiconductor in there as well. So let's try the tricolored LED. Red, 1.82. Green, 2.303. Blue, 2.5. Okay, now we've found out our different types of forward voltages for different colored LEDs. Now there is a different way to do it. A few weeks ago, well, just before Christmas, I've watched quite a few videos, and the one video I liked, and I watch a lot of them, is from BigClive.com, and he had this ESR meter. And I find this quite amazing, because if I take this LED, pop it into here, press the button, we get a 1.9 forward voltage, as you can see with the symbol. Okay, if you can't see that, I'll just move that up so you can see there. Right, so different meters give you slightly different readings. Okay, now I'll just disconnect that. That is just kind of prove the point. Different multimeters, different readings, but they're all around about the same area. Now red is usually around about 1.8 depending. Now these are just kind of your typical LEDs. So we'll bring this multimeter back in. There we go. 1.8. The yellow, 1.8, just below 1.9. The green, 2.3. Now, if I was to put 5 volts into, say, the red LED, it wouldn't last very long. It's probably going to fail. It's probably going to light up very bright, and it's just going to burn out. The only thing that will probably be useful from it is the legs, as links for breadboard. So, what we'll do is I'm just going to show you a little circuit I've made here. So I'm operating on 5 volts, which is pretty much standard in most houses. If you've got a phone, a computer, you've got a limited supply. 5 volts, maybe an amp or two. Same with the USB plug, power bank. You've got around about maybe an amp. Some power banks you can get a little bit more voltage, a little bit more current out of them. So what we're going to do now is I am going to put this on what is decided to be 180 ohm which is this resistor here, as you can see. Now I also want to show you this. If you can see there, we have got our little card with all the resistor color codes on. Now, as you can see, this LED is quite bright, and that's running at 20 milliamps. Now, also, if you can see here, I've got 360 ohm, so I'm going to put the LED under 360 ohm. It's now lowered down approximately 10 milliamps. So I'll do that again, and you can see if I just touch the resistor legs, there is a difference in the dimness, the brightness, if you can see that. Okay, now if I go choose the appropriate resistor for all these LEDs, I will get the right amount of brightness, 20 milliamps overall. I mean, if you look at these resistors, they actually go up in, it's 3. So there'll be 3 ohm, 6 ohm, 9 ohm, etc. Now, if I, like I say, you can look at that brightness, and I put that there. Now if I take another 360 ohm, and I put that parallel to the other resistor, now what happens is, I'll just move the LED down. Now what happens is I am now lowering the resistance because I'm paralleling the resistors. So what happens is, this is pretty much the same as this. But also, I could remove that resistor, put that back there, no, put that there, take this LED, now it's the same thing, the same function. I am about to share that power. So this is the difference between parallel. If I was to do series, it would make it even duller. So here we go. How do we find our forward voltage? What is forward voltage? Now I'm just going to, the best way to describe it is, forward voltage is the minimum voltage required for a device, semiconductor, to operate. So this can happen between LEDs, transistors, diodes, etc. So they need a minimum voltage when they start operating. So some diodes, normal diodes like rectifying diodes, it might be 0.7 volts before they switch on and start to do their work, rectify. But in some cases, like an LED, it would be determining whether it turns on, and if it's slightly above that voltage, get brighter. Now let me show you this. I'm going to remove the parallel LED. I'm going to put it back in over here. Let me show you something. Now I've got 5 volts, that's what we're working with today, and there is the meter. I'm going to just check on the camera. So I am going to take this LED, and the LED is 1.9. That's the voltage the LED is being supplied with. But the resistor is getting, let me just get that right, 3 volts, 3.1. So we've divided or separated the voltage across the resistor and across the LED. The LED is getting around its supply voltage and a little bit more than the 1.8, but now we're also getting the voltage across the resistor, forward voltage. Now, like I say, if I put this over here and I make the LED duller, because I'm using the 360 ohm resistor, I'm still getting the same. Yes, that is reverse polarity, but here we go. So I'm basically getting 3.1 thereabouts. Okay, and it's also using the meter. Now, what kind of resistor do you think all these different LEDs would work on? If I put the same resistor in, so let's try that. I will take the supply away from this LED. I'm going to put it down here on this already prepared board. Here we go. Now I take its resistor, which is the 180 ohm, and I'm going to put it across the switch and the LED and the power supply. There we go. That's quite bright, I think. Now I take it to the yellow LED. It's okay. Are you seeing a pattern? The green's quite bright. The blue, it's okay. Now the violet. Now this is the one from the Christmas tree. This is the one that changes colour. Doesn't look as bright as it did on the tree, does it? Now here we have our tri-coloured LED. So let's put that in there, put that in there. That's our red. Nope, does help if you press the right one. Put it in the right place. There we go, there's our green. And there is our blue. Doesn't look as bright, does it? Because each one of these LEDs requires, compared to its different forward voltage, a different resistor, just slightly different. So the difference between, like I said, let's put this back on, diode. Now 1.8, that's its minimum. It's probably operating maybe about 5 milliamps, sorry. 1.8, just under 1.9, very dim. So this is at its minimum. This is its forward voltage, not its maximum. Okay. So to make sure that we understand that, there are apps, you can even put this into Google if you wanted to. What this would do is give you, so what could you type into Google? Let's have a look. If you wanted to do it this way. So I want a 1.8 volt LED, a red LED, operating on 5 volts, and what would be its required resistor value, and it gives 160 ohms. So I'm using 180, so it's a little bit higher. It does give leeway between, I think, around about 150 to about 180. But that's good because that's a safety. It's not being ran at 25 milliamps or 30 milliamps. It gives the LED longevity. It's going to live a lot longer than if I just go put 5 volts in and then it's just toast. But let's have a look at a different LED. So like the yellow LED, 1.9. Now that says around about 180 to 220 ohms, but that's running it at a lower, basically a lower milliamps. So it's duller. Now when you've got pretty lights and you want like an array of LEDs, you want them to all kind of run at the same brightness, because you can tell if an LED is dull, not by just the camera, but when you're using them, when you're building projects. And the reason why I'm going into forward voltage is to understand that if I go throw a bunch of 150 ohm resistors, which we're going to do now, and I put them in line, apart from the red one, I'm just going to put them all in line. Now, LED, lighting, and put the same all the way across. Yellow, green. The green looks quite bright actually. And then we also do the same with the blue. But the yellow looks dull. Strange, isn't it? But we have different makeup. Well, basically, they've got different types of metal. So when I was on about transistors and other things in previous videos, we have what is basically a N and a P. So we've got, like, in a diode, we've got, like I said, about the cup and the spoon. Yeah? So you've got two different types of, what can I say, negatively, I'm trying to think of the word now. Yeah, so they're coated, one that's in like negative, one that's in like positive, and it's same as like a battery or different types of things that have electrodes. You have to have something that's coated, or I'm trying to think of the actual word that is doped. So it's doped in a negative and doped in a positive, and we have a little link, and when it gets excited, what happens is it emits light. Not all semiconductors emit light. You do get optos and you do get transistors, but also you've got lots of semiconductors, microchips, processors for computers. But with LEDs, they work in a fashion that they emit photons. So we always have two arrows that emit light. So in that little symbol without the circle, we have two little arrows. Yes, I'm cheating the way I've just done that, but they emit. Now, if I was to show you what is on the end of here, this is an LDR, light dependent resistor. Now what this does is this works the opposite way. This actually takes in. So you can have a symbol like this, like a box resistor, but what happens is it's now the photons are going inwards. Same as solar panel. So if you look at a solar panel, they actually take in light to react, and they give a potential, a voltage. So this is the difference, okay? But that is what an LED is. And the thing is, they're great, but they all work on different voltages, different current. I've got some LEDs here from years ago. Now, they wouldn't work the same way on a, probably, what's this, eighth of a watt, quarter watt? Probably not quarter watt resistor. But these little tiny resistors are great for small LEDs, small functions. But they wouldn't be any good for something like a 1 watt, 3 watt LED. Now what you need is something like a LED driver, or you probably, if you wanted to light one of these up on a battery, yes, this LED is going to be super bright, but it's also going to need to dissipate its thermal energy, same as the resistor. The resistor, if I put this resistor to this LED and put it on 5 volts, this resistor is probably going to die very quickly. It's going to heat up, smoke, and maybe we can do that for another video. Please comment and let me know below, but if you want to see that. But it's just basically destroying an LED. Now, they are great. I said this back in the late 80s, 90s. Why are we not using these in traffic lights? Why don't we use them on brake lights and things like that? Obviously, headlights are a different function. They're quite bright. Sometimes you need high beams, low beams, parking lights. But these are, they've come into their own now, LEDs. They're used in many things. But like I say, this is just a little quick video to understand forward voltage. Now, I am going to just explain that you want to find the forward voltage. How can you drop the voltage down to the appropriate power, or the voltage, forward voltage, from 5 volts to an LED? Now, you can probably use many different apps. There's one I've just used today. I'm sure it's changed its name over the years. And I'll just bring up its name, because this is an amazing what's it called? Where's it gone? Just bring that up. Electro dock. Now, dock isn't just for using LEDs. It's great for, now, I used to work with data, trying to send data back and forth. So you would have something called RS-232 or 485. So you want to send data positive, data negative, and ground. Now, if you've got a serial socket, now you need to know out of those 9, 10 pins, I can't remember how many it was, there was maybe 13. You needed to know not just the outside ground, but you needed to know the signal ground, and you need to know the data positive, data negative, data in and out. Now, in some cases, some things only needed 2 wires, ground and data, one way. Didn't need to come back. So, but Electro dock, great app. But you can also just Google things and find things on Google, literally on websites. So, to find out your forward voltage, you need to understand what resistor you need. So we need to know what is the resistance. Now, resistance is equal to what is voltage supply and minus voltage or forward voltage. Now, what you want to do then is find out what the current is, the forward current. Now, to do that, like I say, what we've got is, over here we have our, let's go back to our little LED over here, and we need to understand how to find out between the 1.9, as it's put on here, 1.9, so our forward voltage for the LED, like I show you over here, is 1.8. But that's its minimum. So over here now we're running at about 20 milliamps, 10 milliamps, and now, yeah, so this is 10 milliamps, 1.937. And across the resistor, I'm going to get the polarity right. Come on. We're not changing. Oh, there we go. So now what we've got is 3.1. It's an auto meter, so it changes up and down. Now let me just make sure that this is on the camera. There we go. Now, so our LED is taking 1.926. That's running at 10 milliamps. Now what we want to do is see what takes that extra power away, which is the resistor. So the resistor is basically dissipating 3.1 volts. Now, if this was a lot of LEDs, this resistor would get quite warm over time. It's okay, it's cool now, but that's what you need to do. This is what you need to understand. Yes, sure, you can Google, you can cheat, but I would use your maths, learn your maths, understand the mathematics. Now, this is where we are slowly heading towards Ohm's law. And you will find in Ohm's law we have resistance, voltage, and current. We have power. One way you could look at it is I have a 15 watt supply, not this one, but a 15 watt supply, and I have 5 volts. Now what would be the current, the amps? There's one for you. See if you can answer that in the questions, in the comments. Now, like I say, this is just a quick video just to let you know about forward voltage, how to look at it yourself, how to, when we're building these projects, how to understand lighting an LED, and not to kill the LED so it fails. Give it longevity. Because if we move on now to transistors, resistors, capacitors, and we make something like a flip-flop or bistable oscillator, similar to the tree. So it pulses, charging the capacitor, setting off the bias, the base of the transistor, and pulsing an LED so it goes to the next transistor, the next capacitor. So each stage is triggered. Because that's the next project we're going to do. But I just thought to just give you a little bit of an introduction to forward voltage. I hope you enjoy. Please remember to like and subscribe, and if you have any comments, please let me know. And I am ordering a 4K webcam for better quality, because I have spent the last week trying to find all my audio problems, and it just took too long. I prefer quality over quantity of videos, but this I thought was a good one. So if you want me to, if you find the quality of the video or the audio is not to your standard, please let me know in the comments. And if you want to see a different project or something else, please let me know. Thank you. Thank you for watching. Have a good evening and a good day. Goodbye.